So we're going to start chapter 2, combined with chapter 1 here, and it's going to be talking about states of matter, changes of state, all that good stuff. So we're going to start by talking about the 3 different states of matter. The definition of a state of matter is that it's the physical form in which a substance can exist. So there are some new states that they've been discovering and looking into, but our 3 main ones that we're going to stick with are solid, liquid, and gas. For each of the states, we're going to be looking at if it has a definite or indefinite shape. So does it keep its shape all the time, or can it easily be changed? And definite or indefinite volume. So same, does it keep its volume, or can it easily change? So for a solid, this is a state of matter that has a definite shape and a definite volume. If you have a book is a solid. Its shape does not change and its volume does not change unless you actually are going to, make an effort. You rip a book apart, obviously its shape's going to change. But when it's just sitting there, if it's moved from a table to up to my desk, it's not going to change. It's going to take up the same amount of space, keep the same shape. Particles in a solid are super close together. They're basically locked in. All particles are constantly moving, so they're constantly vibrating, but they're locked into place by all the other particles around it. So if you look in that picture there, that illustrates what the particles inside of a solid look like. They're slightly moving, but they're not changing the position that they're in. They're going to stay locked in. So that's why solids don't change their shape or their volume at all. We have 2 different types of solids. So we're going to start with crystalline solids. Crystalline solids, the particles inside of them are super orderly, so there's a repeating pattern to them, and it's a three-dimensional pattern. So there's an example there in that picture. If you look at the particles there's a very consistent pattern. It's not random. They're all in a very neat order. That's what table salt, the molecules look like inside table salt. Table salt is an example of a crystalline solid. So is ice, iron, diamonds. They're all crystalline solids. So this has to do with the way the particles look on the inside. In crystalline, they're extremely orderly and follow a pattern. Okay, sorry. So we're looking at one that has a completely random pattern. So the particles are still locked in place. They're just locked in a place that there's no pattern to it. So examples: wax, glass, rubber. They're all solids that don't have a crystalline, but they rather have an amorphous structure to them. All right, liquids is our second type of state, or our second state of matter. Liquids have a definite volume, so they are always going to take up the same amount of space no matter where they're at, but it has an indefinite shape. So it's going to take the shape of the container it's in. So if you look at the picture on the right, those are both the same amount of liquid. It's just red dyed water, but same amount of water there, but it's just in 2 different containers. So you can have a glass of water and then pour it into a bowl and then pour it into a completely different cup, and it's never going to change volume. It's always going to take up the same amount of space because water's not just going to appear or disappear out of nowhere, but it's going to change its shape. Liquids obviously take form of whatever they're in. So the reason this happens is the particles aren't locked in like the ones of the solids are. They're attracted to each other, so that they're attached, but they're moving fast enough that they can overcome some of those attractions. So the attractions don't keep them locked in, so they're able to slide past each other. So the particles are going to move around and just take the shape of whatever it's in. So the volume itself is going to stay the same, but the liquid or the shape is going to be changing because of that. All right, so a couple of qualities of liquids that we're going to look at. We're going to be looking at, some properties of water more specifically, coming up here in a couple of days. But these are properties that most liquids have in general. So surface tension is the first one, and this is a force that acts on the particles at the surface of the liquid, hence surface tension. So if you look at the picture on the left there with the paperclip is able to float on top of that water because the particles they're attracted together enough that they form almost a film on top of that water or whatever the liquid is. But If you can kind of see, if you look closely at the picture, you can kind of see where it's almost warped towards the paperclip, because you can see where the particles are resisting that paperclip going through. And then the second one is viscosity. And viscosity is something that we talked about when we talked about our physical properties and did that lab. But viscosity is the liquid's resistance to flow. So if you're looking at something like honey compared to water, honey has a lot higher viscosity than water because it's going to resist that flow because the particles are more attracted to each other than water, it flows a lot more easily. There is gas. So this state of matter is the one that has no definite shape and no definite volume. So gases, the particles are moving so quickly that they can just break away from each other completely. They are not stuck together like a solid. They're not even attracted to each other in the same way that liquids are. They just move freely. So a gas is going to take the shape of wherever it's at, and it's also going to take the volume. So if you have a certain type of gas inside of a jar and you open that jar, that gas is not only going to take the shape of the room, but it's also going to expand within the room. So it's going to just take whatever volume and shape of the place that it's at. So the amount of space between those particles can change, and that's why it can change shape and volume so easily.